Hello, my name is Sean Boyle and welcome to part 2 of this 7-part series on the GM8L90 transmission. This video is going to focus on the mechanical operation and power flow. This slide here basically covers some specs that you'll find in the gear ratios, and the 8L45 is the smaller of the two units, and you can see it has a completely different set of gear ratios than the 8L90 does. And because it's a smaller transmission, you can also see that it weighs a lot less. So it's 176 pounds for the 8L45, where it's 210 or 216 pounds with the 8L90. They will offer, as you can see here, line pressure that we can go through and measure line pressure. They want you to use that Dexron HP fluid. And aside from that, it's your standard rear-wheel drive transmission. And on the side of that transmission, you're going to find a sticker. But the sticker here is very beneficial to us as technicians because that ton number contains a ton of information. It has the plant and the shift, it has the calendar year. Like this one here is a 16, so it was built in the year 2016. And next to that is the Julian date, and in this case that's 232. That means it's built on a 232nd day of 2016. So if you looked at a Julian calendar and figured out what day that was in 2016, you can figure out that this was likely going into a 2017 model. And then of course that 5 UZL is repeated there. And then they've got model number or part info and so forth on there. But really knowing the calendar year that it's built and the model number is pretty important because that gives information on when this was manufactured and maybe if there's updates, if it's going to include those updates from the factory. And also, if you're looking to cross-reference a transmission to find out if it's got compatible parts, this is the information that you can get from that sticker. This is the range reference chart for this transmission. You can see it has 5 clutches. There's 3 driving clutches, 2 holding clutches, and it's a pretty simple transmission as far as that's concerned. It doesn't have any sprags, ratchets, one-way rollers, nothing like that, just these 5 clutches. And their naming of these clutches, you're going to see I'm going to refer to them quite a bit as C1, 2, 3, 4, and 5 because I'm probably never going to remember the 1278R, the 1235R, the 13567, the 23468, the 456, I don't know. There's all these numbers. It's going to be hard to remember those, but you can identify these clutches as C1, 2, 3, 4, and 5. And this is the range reference chart, which if you have shift issues, more than likely you're going to resort to a range reference chart like this to be able to figure out what clutch is supposed to be applied and when, and maybe what clutch is coming on if you've got a harsh shift or a flare, what clutch is responsible for that, what clutch was off and then now it's trying to become on and it's giving you that flare. Because this is a clutch-to-clutch transmission, meaning that when I shift from one gear to the next, they have to release a clutch and apply a clutch. They're not going to be able to rely on one-way clutches like a lot of transmissions where all you have to do is apply a clutch and let a one-way clutch freewheel. They don't have that, so they've got the timing and the precision has got to be right on the money on this transmission. That's the reason why if you watch the overhaul video or even later on in this video, it's very important that you get clutch clearances correct, that the valve body's good and sound and doesn't have excessive wear or anything like that, because this transmission's really hypersensitive to the operation of the clutches, and those are controlled by solenoids, which are controlling valves. So everything needs to work in harmony for this transmission to work perfectly. Whew. So anyway, this is the range reference chart. So this is what you're going to refer to if you've got issues with any particular shift to see which clutch is responsible for that shift. And you can see there are pretty active clutches there. Our C3 clutch, which is right here in this blue column, you're going to see 1st, 3rd, then 5th through 6th, 7th, and then it's going to release in 8th. And even our 2, 3, 4, 6, 8, which is in this purple column here, you're going to see it's pretty active too. It comes off after 4th and back on for 6th, then off for 7th and back on for 8th. So there's a couple clutches that see a lot of activity, a lot of shifting. So those are the clutch circuits that when we look at the valve body, we're going to pay a lot of attention to. Well, we're going to pay attention to everything, but those are the things that maybe are going to see the accelerated wear. And when we're into the unit, mechanically, we're going to look at those clutches and make sure everything's in good shape. As far as this construction of this gear set is concerned, they've got 4 planetary gear sets. It's not like the 6L80 where they've got the lapel TA gear train or anything like that. They're just standard gear sets. And we're going to go through and build this gear set up basically from scratch and explain what's connected to what, and then how it's operated in each gear. And looking at this illustration, starting all the way over here at the end, we've got the output shaft. You can see this output shaft has this little spline assembly to it. It actually splines into this output carrier. And on the inside of there, they've got this tiny little output sun gear. They call it the output sun gear. Now, these are GM terms. They don't quite make 100% sense. Like, for example, if I'm going to call that the output sun gear, you would think that's connected to the output shaft. Well, it's not. It's actually connected to an input drum that shoots all the way through the gear set assembly and grabs onto that. But you can see that the kind of the trend that GM's got going here is they're calling everything towards the back here output, everything that's kind of in the middle here reaction, everything that's towards the front in input, and then once we get to the very front, they're going to call it the direct and overdrive. So don't use the terms as they are physically connected in those positions. Like an input part doesn't necessarily have to be hooked up to the input. I know it doesn't make sense, but GM's like that. They've been doing that for years. They used to say everything on the front half of a gear set was input, everything on the back half was reaction. It's just their way of naming things. So anyway, these are using the GM terms. So if you ever had to buy a part from a GM dealership or something like that, these are the terms that you would end up using. But yeah, so we have the output sun gear and the output carrier assembly. And that's the parking pawl that we have there. And then the small tooth wheel next to it is the tone wheel that the output shaft speed sensor is going to hook up to, or not hook up to, but read off of. This is the reaction carrier assembly. It also has the rear, I guess the fourth planet internal gear. And then this would be the third planet carrier. And that's the tone wheel for it. So they call this like an intermediate shaft speed sensor that's going to read off of that tone wheel. But then we have a reaction internal gear, and you can see it's got a set of splines on it, and those splines right there are going to be what the C2 clutch grab onto. And then we have this, what they call an input sun gear, and there's actually a sun gear, a common sun gear that's shared between the second planetary gear set and the third planetary gear set, and this set of splines that we have right here is what the C1 clutch is going to grab onto. So it can stop that assembly from spinning. Then I have a input carrier, and that is actually a good term for this carrier assembly. And the reason why is because it is splined to a drum that is connected to the input shaft. So it truly is an input carrier. It's always being driven by engine speed. And then these gears that kind of fit inside that shell, and actually they fit inside another drum that fits right here. It's not shown, is my input internal gear, my direct and overdrive carrier, and then my direct and overdrive internal gear. So these are part of the front planetary gear set and the second planetary gear set. And really, this is part of the third planetary gear set, and then all the way towards the back is the fourth planetary gear set. So this slide here, I added the clutches and I added that input drum assembly, mainly because it's connected. You can see this little arrow right there. It goes all the way back and kind of connects to that rear sun gear. Well, this set of splines right here shoots all the way through the center of this gear set, you know, right through the middle, and it grabs onto that sun gear. I actually got it pictured twice. The sun gear is already pictured on that shaft, and then it's that same gear that's located right there. So anyway, yeah, now this shows how the clutches and where they're connected and kind of their labeling. I know, like I said, it's kind of confusing at times because it doesn't really make sense. Their order doesn't even make sense. We have the C1 clutch right here that grabs that input sun gear assembly, and that C2 clutch that grabs onto that reaction internal gear assembly. So like I said, that's C1 and 2. Okay, don't have a problem with that, but when we go towards the front, we've got the C4 clutch located here, which is the 2, 3, 4, 5, 4, 6, 8. And then we've got the C5, which is the 4, 5, 6, 7, 8R, and then the C3, 1, 3, 5, 6, 7. The C3 clutch is another drum that's not pictured here that's connected to the input shaft, and when it applies, it can drive that drum right there. So it actually drives this drum with engine force, or turbine force, because the C3 clutch is connected to the input shaft. So it'd be input shaft into this drum assembly, and then if the clutches inside here are applied, they can drive these parts of the gear set. Or if nothing else, you know it's driving that sun gear all the way towards the back. So we'll look at that more when we go through and build this transmission up and explain power flow. But those are the pieces and parts of the inside of this gear set. And it is easy to come apart and put back together, pretty straightforward, but sometimes trying to get your mind wrapped around what each piece and part is doing for all 8 gears, having a little range reference chart up there, in the corner, that's helpful. But yeah, 3 input clutches, 2 brake clutches, and then 4 planetary gear sets. So on this short little video clip here, I basically cover the same thing, but on this assembled gear set unit here, and I cover which clutches go where and kind of the naming of the parts. So looking at this whole assembly put together, right here towards the left side of the screen here, we've got the output shaft. Inside there, we have the output sun gear, which you can't see, obviously. On this tone ring, we've got the output carrier. And that's splined all the way up towards the front where the output front carrier is. They call that the input/overdrive carrier. But the next in line, this is the parking pawl mechanism that we've got for on the output carrier. So that way when you put it in park, it kind of lugs into that spot. This right here is part of our reaction carrier, and it's a rear, like a 4th planet internal gear and a 3rd planet planetary gear set. And this assembly right here, where our holding clutch, our 1, 2, 3, 4, 5R, or our C2 holding clutch, that is what we're looking at right here, and that's the lugs that the clutch assembly are going to grab onto. And right here we've got our input sun gear. There's actually 2 sun gears that go between the 3rd planetary gear set and the 2nd planetary gear set. And these lugs right here are for the 1278R, or the C1 clutch. Then we see our carrier assembly, and that carrier assembly, the 2nd planet carrier assembly, it travels all the way to the front and it lugs into the C3 clutch housing, the 1, 3, 5, 6, 7 clutch housing, which has the input shaft built into it. So this part is the component. This 2nd carrier is the part that's always being driven. And you can see inside this shell assembly right here, we got this set of lugs here. That set of lugs is connected to the input internal gear. And the clutch that grabs onto it is the 2, 3, 4, 6, 8, or the C4 clutch. And this other set of lugs that we see, that's part of the direct and overdrive internal gear. And the clutch that grabs onto it is the 4, 5, 6, 7, 8R, or the C5 clutch. So not pictured here is the 1, 3, 5, 6, 7 housing that is going to basically grab onto these splines right here that basically will allow the input shaft then to drive this drum. And when this drum is being driven, it can directly drive the rear sun gear, or with these other clutches applied, it can go ahead and apply the internal gears for the 2 front gear sets. Now that we've gone through this gear set assembly, let's go through these clutches a little bit closer. And the first one we're going to talk about is the first one you pull out of the transmission when you take it apart. It's the C3 clutch, or the 1, 3, 5, 6, 7. Those are the gears that it's used in. And its job is to drive this housing right here. When we apply this clutch assembly, you can see the clutches over there. When we apply that clutch assembly, it's going to drive this housing. This housing is going to either drive the 1st and 2nd planetary gear sets internal gear assembly, so we're going to be able to drive either one of those gears. And we're also going to be able to drive this input shaft that goes all the way to the back and drives that 4th planetary sun gear. So this clutch assembly is going to be equipped with either 4 or 5 frictions, depending on the code that you might find on it. When you look at the end of it, or really it's the front of it, it's going to be an A or a B. A is going to be 4 clutches, B is going to be 5 clutches. And depending on how many steels and frictions you've got in there is going to determine what the clutch pad clearance is. So now apparently they updated in 2019 the return spring assembly, and I don't have one to show you, but they say it also does not work on the earlier units. So they must have changed something with the piston or maybe possibly the drum, but they did do an update to that in 2019. Now their clutch pad clearance measurement is a little bit different. It's a little bit unique. You see some manufacturers kind of going towards this, but they are definitely doing this on 4 out of the 5 of their clutch assemblies, where they want you to place a load on the clutch, and it's not a heavy load. It's just, in this case here, this C3, and it's different for every one. And this one, they're only putting 30 pounds of load on it. This clutch assembly does not use a wave plate, so maybe that's the reason why. but they only put 30 pounds of force, and really, in my opinion, that's kind of to take out any irregularities that may exist in the frictions and steels, to kind of take out any of the gap from waviness or something like that. And then in that situation, you zero your dial indicator with that load on it. Then you remove the load, use air pressure to stroke the piston, and then you reapply the load. You go back and apply the 30 pounds of force again while it's after the piston's already stroked. And whatever your dial reads is your clutch back clearance. And now I do later on in this presentation talk about basically if you did it a traditional method and just use the dial indicator and either use air pressure or hand pressure to move it up and down, what does that compare to as if you use the load? And you're going to see it makes very little difference at all. But this is the procedure as labeled out in the service info, so it's not a bad idea to follow it. So looking at the specifications for the C3 clutch, you're going to find, remember, there are two different clutch counts in these. So depending on what your clutch count is, it's going to change what your spec is going to be. So a 4-plate spec is going to be between 72 and 91, and the 5-plate spec is going to be between 59 and 83 thousandths of an inch. And that's for a total spread from minimum to maximum of that range of either 19 thousandths for the 4-plate or 24 thousandths for that 5-plate. So that's a pretty tight target to get. So when you're doing these measurements and using that special tool or even doing a traditional method, you want to go through and do that actual measurement and make sure that you're within the spec. If you're not, they've got these 5 snap rings that you can change between. And I've even put the part numbers off to the side here. Those part numbers, you're going to see when you run these things in a program like Repair Link Shop that they're cheap. They're only like $2.50 for a snap ring. So it's not an expensive adjustment to do. Matter of fact, as a shop, it wouldn't be a bad idea to get a couple of every size, keep them in stock, and then you could just switch them out so you're not having to wait, have a transmission on a bench waiting there for a snap ring. But they come in about a 14 thousandths of an increment. So if you need to make an adjustment, just realize that every step, either up or down, is going to likely change it about 14 thousandths of an inch. And that will get you close. And it is important on all these clutches, and I'll just mention this that one time, that you do spend the time, do these clutch pack clearance measurements, because these tight windows that they're shooting for, remember the amount that that piston strokes inside this clutch housing, that's the amount of volume of transmission fluid it takes to fill that up. And these transmissions really don't have any accumulators. You're going to find they've got these tiny little solenoid accumulators, but they really rely on the computer assuming that the mechanical side of things are within spec. Meaning the computer is going to expect that the clutch clearance is within this range, so that way it can adapt as needed as it's applying these clutch circuits, filling them up, draining them back, all that kind of stuff, knowing that there's a certain amount of volume in that clutch housing assembly. And like I said, the volume is dictated by how far that piston travels. If it travels really far, it's going to have a larger volume of fluid that's necessary to stroke that piston. If it's traveling very little, it's going to require a very little amount of volume, but it's expecting a certain amount of volume, and it's dictated by the clearance that our clutches actually stroke. Now in this video, I go through the process of load testing and clearance checking the C3 clutch assembly. You can see I've got a little, kind of some homemade devices here. You know me, I'm not big on buying tools. I'll buy them. I'll buy the special tools if there's no way around it. But if I've got stuff around the shop that will work in its place, then I'm going to use it because I'm a persnickety fella. But right here, this is probably the most common special tool found in any transmission shop, which is a broken 4L60E reaction sunshell. And I'm using the typical screw press that you do to remove clutch spring retainers and so forth like that. Got my dial indicator clamped to the side of it, and I'm measuring the actual movement of this clutch assembly by basically just placing it right on top of that reaction sunshell, placing it off towards the edge so there's less deflection in the stamped steel shell. And here we go. So you can see I've got that, applying that down. And there's my reaction sunshell, and I'm loading it. That's what this is, a little load gauge right there. And I'm putting the 30 pounds of force on it. So it's actually taking out all that irregularities, if you will. Now I'm zeroing the dial indicator with that load on it. So that dial right there, my dial indicator is reading 0. Then I took my load off. and you could see that gave me, looks like it deflected a few thousandths of an inch there, actually 12 thousandths of an inch. Now I'm going to use air pressure, and I lifted that piston up, and you can see everything cycled around, and now I've got 83 thousandths of an inch. So that's the travel. But following the service info, they want you to reapply that load again. And the reason why they're doing that is they're going to recreate any of the deflection or flex that might occur when you're zeroing it at the bottom. They want to take into consideration any of that stuff by reapplying that load when it's at the top. Then the net result is your actual clutch pack clearance. And that next clutch that we're going to cover here is the C5 clutch. It's located inside this drum assembly right there. It's the one furthest down in it. You can see on the bench here I've got listed as 95 thousandths. That's actually the thickness of the snap ring. But the C5 clutch is the assembly that's circled here. And I've got 4 steels, 4 frictions, a wave plate, a backing plate. And apparently they changed the frictions in 2019. Like I said, I don't have one of those units, but that is something that they supposedly changed. And they also have 7 adjustable or different thickness snap rings. They're not adjustable snap rings, but you know what I mean. They're snap rings that you would change to gain your adjustment. And it's the same part number for those snap rings between the C4 and the C5 clutch, so those same 7 work in both those positions. The end play that we're looking at is 49 thousandths to 75 thousandths, and the snap rings have a wide range. They can go from 69 thousandths up to 157 thousandths. You can see I'm pretty much right there in the middle of that spec. And when we look at the pistons inside this housing, we're dealing with this smaller set of pistons, and that is a spring retainer. They use a diaphragm type spring. That's the actual piston, and this device right here pretty much separates the C5 piston components from the C4 piston components. On that clutch pack, since it does use a wave plate, they actually want you to put 75 pounds of force on it, then zero the dial indicator, remove the force gauge or load gauge, stroke the piston with air, and then reapply 75 pounds of force, and then use that as your measurement. And you have a 26 thousandths of an inch window between minimum and maximum, and there are 7 snap rings that you can choose between, 14 thousandths of an inch approximately increments to fine-tune that and get that clutch pack clearance perfect. You can see here that the prices of these are not too crazy. Once again, mostly around $2.50 to $3, and those are the part numbers for those different snap rings. In this video here, I'm going to show you the clutch pack clearance test on a C5 clutch. And I had to do this one on a press. The reason why I had to do it on a press is because my little screw press assembly that's benchtop, it's just not tall enough. Now the GM factory tool that they want you to buy is really tall, but it's also really expensive, so we don't have one of those. But we do have a couple nice hydraulic presses here. So that's plenty big. We can put it on and I can control the pressure to get that 75 pounds of force without any problem. So that's the reason why we're kind of shifted over onto this apparatus here. Now you're also going to see a couple special tools. I'm going to end up using a 4L60E forward clutch housing to go deep inside of this drum, and that forward clutch housing will kind of go around the shaft, and then it'll slide down and contact the backing plate for that C5 clutch assembly, and it will kind of bypass this C4 clutch assembly. So it fits within the C4 clutch assembly without touching it and rests on that C5 backing plate. And then I will use my 4th clutch hub cookie cutter. That will slide right over the input shaft here and push down on that forward clutch housing assembly. So they do obviously make the special tools that they want you to go out and buy for all these. But once again, the concept is there, whether you're using their tools or not. They want you to apply a load on this clutch pack assembly, measure the stroke of the piston with the dial indicator, and as long as you've got tools that can do that, you don't necessarily need to use the factory tools. So here I'm grabbing that 4L60E forward clutch housing, and that is going to go right over the shaft, drop right in there real nice, and fit on the backing plate for the C5 clutch. So that way the C5 clutch is in contact but not the C4. Then I take my 4T65E cookie cutter, and that's going to allow me to apply hydraulic pressure down onto that forward clutch housing. And that's going to allow me to basically place the load from my load gauge onto that clutch pack assembly. There's my little load gauge, and you're going to see down here at the dial we're going to, when I apply 75 pounds of load, you'll see the amount of deflection that it took. Okay, it's kind of fast forwarding through all this stuff here. And I got about 8 thousandths of deflection, maybe 10, looks like it's moving slowly. So about 10 thousandths of deflection when I applied the 70 pounds of force. And that's the waviness that existed, if you will, in the clutch pack, the unevenness. And then I zeroed it, I zeroed my dial indicator, and now I'm going to remove my force gauge or load gauge. And if you look, when I do that, the dial indicator moved, and the apparatus rotated on me a little bit, but at this point I need to use air pressure to cycle that piston up. And there you go. You see that that dial just lifted. I just applied air. These black lines there at the bottom, those are delivering air pressure into that. And now I got to go through and reapply that load. I got to put that load gauge on there. Once again, that is to take into consideration any of the deflection that could have occurred. When I zeroed the dial indicator at the bottom, I want to go through and do that again, kind of put it under the same state, if you will, or the same conditions. But this is a 20-ton press. It probably didn't deflect at all with 75 pounds of force. And as you can see, I got about 62, 63 thousandths of clutch pack clearance. Nothing changed once I put the 75 pounds of force on it or load. So that is what I got. And this is that air test tool. I had to make that air test tool myself because the GM one was on back order for like months. So basically, if you've got a lathe and a chunk of aluminum, you can machine this out. I just drilled it out the right spacing, cross-drilled the end of it, and put some air fittings in there, some quick disconnect couplers, and basically pounded some check balls in there to seal off my cross drills, just like they do when they make stators and input shafts and all that stuff. These drums air test tight as a drum. I guess that's where the saying comes from, tight as a drum. But there's no air leakage. You don't hear it. When going through an adapter like this, when you put air into it, the clutch applies and you shouldn't hear anything leaking. So if you're hearing something leaking, either there's a problem with this or you got a problem with your seals, a crack, or something's going on and you need to address that, because those 3 driving clutches should air test perfectly tight with no leakage at all. Now when we move over to the C4, that's the other clutch assembly, that's the top clutch assembly if you're looking into that drum, and you're going to see that they've got, in that clutch assembly, they've got a wave plate, they've got an apply plate, 4 steels, 5 frictions, and a backing plate. So you actually have the wave, a little thicker flat plate, and then your normal frictions and steels, and then the backing plate. It uses those same 7 selectable snap rings that the C5 clutch used, and the end play that they're shooting for is between 61 and 87 thousandths of an inch. It's the piston assembly that's located deeper into that housing. It's after that divider that we see when we pull the C5 piston out, and we've got the divider, and everything else in there is the C4. That's the spring retainer. We've got our dish spring right here, dish facing down, and then we've got our piston assembly right there. The piston's a little unique. It's got this, if you can see it there, that little notch cut out of those. There's like a little double notch that lines it up inside the housing, and then we have a ply ring. It's like the first thing you put down in there for the clutch assembly. That actually has a notch that fits inside that special spot on that piston assembly right there. And you can see on the description here, they changed it in 2018, so make sure you are using the right seals for the application. Your seal kits are going to include 2 different types of seals or 2 different size seals, and it's going to, depending on what year unit, and that's where you're going to look at that sticker on the outside, depending on what year your transmission is going to determine what set of seals you're going to install. The only clutch assembly that uses a molded piston in this transmission is the C1 clutch assembly. All these others have replaceable rubber O-rings or D-rings. So it's one of those few kits now that when we go through, we actually replace all the seals as opposed to replacing the actual piston assemblies. If we look at the clutch pack clearance on it, you're going to see that we have, once again, a 26,000 spread, just like it was on the C5 clutch assembly. It's using those same snap rings, and it's the same part number, same prices, and they come in that 14 thousandths of an inch increments, roughly, thereabouts, and we're looking at that 61 to 87 thousandths clearance. They're going to want you to put 60 pounds of force on this clutch assembly and use 50 pounds of air pressure to stroke that piston. So let's look at the process of going through and checking our C4. This drum right here is a clutch hub out of a 6L90. And it fit there perfectly, so why not use it, right? And I'm going to go through and put my 60 pounds of force on there. Once I've got about 60 pounds of force, hydraulic press is a little crazy. It kind of goes over, then I back it off, and I kind of get it to where it needs to be. And then I got to go through and zero my dial indicator. And you can see once I release this load, I got about 10 thousandths of an inch, about 10 or 11 thousandths of an inch of deflection. At this point, I got to pump air into that piston assembly, and it's going to move that up. Looks like it went about 95 thousandths of an inch. But then I got to reapply my load gauge so I can take into consideration any deflection that might occur in my testing apparatus. And now I'm back down to 92-ish, maybe 91 thousandths of an inch for that clutch assembly. Now looking at the C1 clutch, that's actually a holding clutch. That's when we're taking this assembly apart, that's the first holding clutch that we have in the case. And you pull this clutch housing out, and if you look, there's the molded piston. That's the only molded piston that we've got in this transmission. There's our return spring. And then this like aluminum apply ring, that's going to take the force from the piston and apply that to the wave plate. So we've got a wave plate, an apply plate, 3 steels and 4 frictions, then a backing plate. And the piston return spring was updated in 2018. Apparently not something that you're supposed to retro back if you've got an earlier unit. And there are no selectable snap rings or plates or anything like that in this unit. So basically, if some clearances don't seem right on that, you likely have it together wrong. Now the 1, 2, 3, 4, 5R, or the C2 clutch, that actually is adjustable. And it's, as you can see here, it's actually part of the tail shaft housing, and the piston fits inside this housing here. This is the apply piston that we have right there. That's the return spring and the retainer for it, the snap ring. And on this clutch assembly here, we've got a wave plate, an apply plate, which is a little thicker, 2 steels and 3 frictions, and a backing plate. There's a little larger spread on this one here. You allowed up to 35 thousandths of a window between minimum and maximum. And once again, the snap rings are in 14 thousandths increments. Not quite certain what's going on here. Most of the snap rings here are like all the others, around $2.50, but the largest one for some reason is $23.59. So that one, hopefully you won't need that one because that's an outlier. It's almost seems like they got a decimal in the wrong spot on that one for some reason. So on that C2 clutch, you use 80 pounds of force, and since it's in the case, you need to kind of put a crossbar or something across the bell housing and a little screw that kind of goes down, pushes down on everything in there, and use your load gauge. And because it's further down in there, you're probably gonna need some extensions on a dial indicator to go down and contact all that. You can make it work, as you can see in this video coming up. I actually do have this crossbar, this adjustable one, so I use it, but aside from that, I just kind of come up with different things to kind of build that up. But yeah, you want to place 80 pounds of force, zero your dial indicator, use 50 PSI. Now it is kind of an oddball shape that you apply air pressure to, so I made a metal kind of out of aluminum. I made a little test plate, if you will, that I can bolt in place and apply that 50 pounds of force. It's nice to have stuff like that even when I'm going through and air testing it. As you've probably known, if you've tried air testing, things that aren't perfect circles, it's hard to get the air nozzle to seal off on it, and sometimes just having a plate with a hole drilled in it, if it's a large opening there, it likes to squeak and lift off and doesn't seem to work very well. So in this case, I've made myself a little adapter. It only took about 10 minutes, and it works pretty good. Once again, the old trusty 4L60E shell, and drop that in there. It just seems to contact on that backing plate fairly well. Anyway, here's my load gauge. You can see I'm tightening that up, and I'm just going to go through and apply the 80 pounds of force. So here I'm zeroing my dial indicator with the dial indicator kind of located towards the edge of that shell, so that way the shell's not deflecting under that 80 pounds of force. That's kind of what I'm pointing at there, is that I'm not measuring it towards the middle, I'm measuring right there towards the edge. So I got my 80 pounds of force, I'm zeroed out. So now I know I've taken out the unevenness, the waviness. So next I'm going to go ahead and take off the load gauge, and I'm going to apply air pressure into that pressure port and stroke the piston. And there I just stroked the piston. You can see there's no load gauge on there. But now I got to go through and reapply the load in case there was any deflection in my setup. Not to sound like a broken record, but the only reason why they have you reapply the load is because if you're flexing things when you're zeroing it out when it's released, you should at least reapply that to make sure that same amount of flex from the force is present when the piston's down and up. And you can see it had very little change on that dial. I got about 95 thousandths of clearance. So here's the long and short of it, and you're probably wishing I would have shown this screen to begin with. But I did a little study here, a little comparison, because all those special tools and fixtures and coming up with parts and pieces around the shop to make that all work, that all takes time. But the traditional method that we use typically to check clutch pack clearance involves put a dial indicator on the backing plate or on a clutch, you push down, zero it, and then you lift it up and you measure it. You just kind of measure that movement. You push it down a little bit to take out all the unevenness in a clutch, zero it, and then lift it up. Well, you can also do that with air pressure. You can push it down, zero it, and then use air pressure to lift it up. Or you can use that load gauge, which is push it down with a specific load, remove the load, air pressure it, and then reapply the load. Well, I did that study on all of these clutches, or not all of them, but these three right here, just to give an example. And these are the results. Inside this red box, this is pretty much the result of what I've got. This first one right here is if I use my hand only, pushing down and lifting up by hand, I was getting 78 thousandths. And this is using used clutches, and they were good. They weren't burnt or anything like that. The second one is if I use air instead of my hand. You can see I got the identical measurement. And then this next one was if I used the force gauge. So apparently I was pushing down on it probably harder than the force gauge. If you remember that force gauge, you only told me to push down with 30 pounds of force. I was probably overdoing it a little bit because with the special tools, I was only getting 73 thousandths. So I was actually getting a little less clutch pack clearance measurement than by hand than I was if I were doing it with their specified way. On the C4 clutch, you can see with the used clutches, both of them were 90, whether I was lifting it by hand or lifting it by air. And then with the tool method, the published service manual method, I was getting it done with 90 thousandths movement. So, I mean, within a thousandths of an inch of each other. The C5, same thing, 55 and 55, and then I ended up getting 57. So the C4 and C5 required a little bit more load with the load gauge than the C3, so that's why I'm assuming that the C3 was a little lower than what I was doing by hand. But anyway, you can see here that they're really close, whether you're using the special tools or not. So if you don't have the special tools, I don't think that you should just run away from this transmission. I think you could still just use a traditional way to check it. Now this is that same measurement, but here I'm using new clutches that are dry. I haven't been put any oil on them. They're not the used clutches. I got new steels and new frictions. And you can see similar measurements, 75, 76, 75. That's using the hand only air. So I got a thousandths more movement when I put air on it. Then when I went back to the force gauge, I'm back to 75 thousandths. And then on the C4, it was 89, 89, 90. So within a thousandths of each other. And then the C5, 54, 56, 61. So this is the one that changed the most. I don't really know why, but I did actually get about 6 thousandths more movement than if I used my hand only by comparison, using dry clutches that were brand new. Now after I soaked those clutches for 15 minutes in ATF, I redid the test again. And you can see I got 75 thousandths when I used the hand measurement. When I used hand pressure down and air pressure moving up, I got 76. And my force gauge was 75, so really that didn't change at all. And then on the C4 clutch, I got 89, 89, 90. That didn't change at all. And then with the C5, once again, I got a greater change or a greater difference there. I got 52, 55, and 60. So it did seem to make a bit of a difference on the C5 clutch assembly. Once again, it's only 8 thousandths. That's not drastic, although we do have a fairly tight window to achieve. I'd say that the only time I'd maybe be concerned is if when I use the traditional method, if I was on the edge, the extreme edge. If I was in the middle, I know I'd be good. Matter of fact, if I was on the low end of the spec or in the middle, I think I'd be good. If I was on the high end of the spec, I'd probably worry that maybe doing the proper method, using the proper tools, that I would kind of maybe exceed my clutch pack clearance a little bit. So I would shoot for the middle or lower end of the spec if I was using a traditional method, then I'm be pretty confident that those clutch pack clearances would be A-OK. So these next slides, I'm going to go into this gear set construction and kind of build it up. And if you've seen any of my other transmission videos, I kind of build up this gear set in a little PowerPoint, if you will, in a little fashion where maybe we can understand what we're looking at gear-wise as we kind of break it up into these pieces. And I know looking at this is really confusing, but in a second here I'm going to break it down. All these colors mean something. These are our 5 clutches right here, and everything that's connected in a particular color is kind of related to each other. So starting with this, we've got our output gears right here. So these are all output shaft related stuff. And this is a kind of an illustration of my front planetary gear set. These would be like the little planetary gears, and since I've got that line right there that's connecting them, showing that that's a front planetary carrier. And then going all the way back to my 4th gear set, this is a planetary gear here, and these little black lines show they're connected. That's part of the planetary carrier. And this is what it looks like. So here's my front planetary gear set, there's the shaft, there's my rear planetary gear set, and then there's the output shaft. So we know that no matter what, either the front planetary or the rear planetary is going to be delivering the output torque depending on what gear we're in, reverse or 1st through 8th. Now building this thing up from the back to the front, I've got a gear set that doesn't have any clutch driving it or holding it, but it's basically the rear internal and the 3rd planetary gear set's carrier assembly. They're all connected and intersplined, and I've got that drawn as 3. So it's a way of connecting the rear gear set or the 4th gear set to the 3rd gear set, and it's a common gear that my rear internal and 3rd planetary are common. So this is that rear internal, 3rd planetary. If I assembled that onto that gear set assembly, you can see that rear internal, 3rd planetary. When I say they're common, it means like if one's spinning, the other's spinning. If one's held, the other's held. Now the next gear set I have up here is the 3rd planetary gear set's internal gear assembly, and that fits around the 3rd planetary gear set's carrier assembly. And the clutch assembly, the 1, 2, 3, 5R or the C2 clutch, that clutch assembly, when it applies, it keeps that 3rd planetary gear set's internal gear from rotating. And to look at it on the illustration, you can see these are the splines that C2 clutch will grab onto, and that fits that. So this component right here is that component right there. And once we put that onto the gear set, you can see it covers that 3rd planetary gear set's planet gears. Next, we add on what they call the input sun gear assembly. You can see it's all in blue here. So everything in blue, that fits the 3rd planetary gear set sun, but it also has the 2nd planetary gear set sun. So, and the 1278R is the holding clutch that could hold this dual sun gear assembly. So when that applies, it keeps the 3rd planetary gear set and the 2nd planetary gear set. It prevents that sun gear from rotating. And to look at it on a picture, we've got here, that's that assembly. There's a sun gear right there, the rear sun. And when you slide all that onto the gear set assembly, you can see that's right there is where the C1 clutch grabs, or the 1278R. Now I add my input carrier assembly. It's all in red. So meshing around my input, my 2nd planetary's input sun gear, is the input carrier. And if you remember, that's part of that big old shell that goes all the way over to my input shaft. So torque from my turbine and my torque converter comes around and drives the 2nd planetary gear set's carrier. How about that? This is what it looks like. That's the shell and the carrier by itself. And then when we pluck that thing on to the front of this gear set, you can see it goes around and it drives that 2nd planetary gear set's carrier. And now I've added in green here the 2nd planetary gear set's internal gear assembly, and wrapped around in part of that is the front planetary gear set's sun gear. So the P2 internal gear and P1 sun gear are common. They're all part of that same component. And this is a picture of that. So the assembly by itself, that's the P2 internal gear. On the inside here would be the P1 sun gear, and that would slide right on the inside there. These lugs right here are what the C4 clutch are going to grab onto. The C4 clutch part of that C4, C5 clutch housing. It goes in there and it has the ability of grabbing onto this 2nd internal gear or front sun gear assembly. So lastly, you can see we've got the internal gear for that P1 from that front gear set. So at this point, the gear set's completely assembled, and my 4, 5, 6, 7, 8R, or the C5 clutch, is the component that has the ability of driving that P1 internal gear. This illustration also shows all of the driving clutches now. So the C4 clutch is my 2, 3, 4, 6, 8, and that drives this internal gear, this P2 internal gear, and the P1 sun gear. The 4, 5, 6, 7, 8 R is my C5 clutch, and it has the ability of driving that internal gear assembly right there, the P1 internal. And then the 1, 3, 5, 6, 7 is my C3 clutch. And what it does is it allows my input shaft to drive the housing that contains these two clutches. And here's that picture where we take that front gear set, the front internal, and that's fitting right in there. And the C5 clutch has the ability of going in there and driving that part right there. Easy peasy. Now when I take that input drum assembly and I install that whole assembly in there, it's going to go all the way through and it's going to drive that last planetary gear set. It's the P4 sun gear assembly. And that's it. Those are all the parts. It's amazing. A marvel. Engineering marvel here. We've got all 4 planetary gear sets, but we only have 5 clutches, and that gets us 8 speeds in reverse. This video here is just pretty much a little add-on. I just stuck this output shaft in the end of the bench, and I just put parts on it from front to back. It's kind of fun. You should try it sometimes. There's my output shaft. Slid my sun gear in there. The little sun gear is easy to forget. Be laying on the bench. It's laid right on in there. There's a Torrington bearing right there. Keep parts separated. Another Torrington bearing. Then you can see my tone wheel there. Oh, where'd that extra set of hands come from? There's a spot there for my C2 clutch assembly and some more Torrington bearings. And that would be the reaction internal gear up towards there, towards the back. There's my C1 clutch assembly. You can grab onto that hub. And I've got my second planetary and third planetary sun gear assembly. Just showing you there, well, that's like a little spacer. It's actually got these teeth that fit on there. And then a Torrington bearing. It's almost like a place for that Torrington bearing to contact, but I can't put that on yet because I have to slide this input carrier assembly on. I'm showing those plastic thrust washers. Slide that on. Nobody's foot got hurt in this process. It was amazing. So I'm going to slide that plastic. That's the part that I put on just a second ago, but just to show you. So I'm sliding that plastic thrust washer on there. They give you that in a kit, which is nice. I then put my Torrington bearing on. Now I've got my P1 sun gear, P2 internal gear that fits around that carrier. And then I got my output carrier assembly. That the inner splines there, spline to the output shaft, and there's a nice Torrington bearing there for you. And then I've got my front, the P1 internal gear. That's what the C5 clutch grabs onto. How about that? Pretty simple. The only thing I didn't slide in there, because I was worried about it falling off and breaking a chunk out of the concrete, was the drum assembly that can go in there with the input shaft and just connect itself with that rear sun gear. And when you go to install that, when you're rebuilding them, you actually slide the 2 internal gears that are located in the front. You preset those inside the housing, and then you assemble that as a unit, just kind of like the reverse of delivering a baby. You just take it all and put it back in like that. But it works pretty good. And now we're going to go through powerflow. Powerflow in this transmission can be a little confusing at times, but we'll figure it out. This is first gear. First gear is actually a pretty simple one. By having my C3 clutch applied, my input shaft is going to deliver torque through this housing and deliver torque all the way to that sun gear. And since that rear carrier is output, and I've got a rear sun that's input, and if you also look, I've got these 2 holding clutches held. So if I'm holding both of these clutches, that pretty much locks down this gear set, including this rear or the P4 internal gear. So if my P4 internal gear is held stationary and my P4 sun gear is input, my P4 planetary gear set is going to be output at a gear reduction. And that's what they do for first gear. And here's somebody much smarter than me explaining that.
Starting with first gear is pretty easy. We have these two holding clutches, the C1 and 2 clutches are being held. And what that effectively does is it holds the rear internal gear, prevents the rear internal gear from rotating. And then I do always have my front carrier spinning, but it's not really effective in first gear. But by having the C3 clutch, the 1, 3, 5, 6, 7 clutch applied, we're going to apply torque to that shaft that's in here that goes all the way to the back and drives that rear sun gear. So what my output's going to be is that rear gear set with the sun gear is being input, the internal gear being held, and the carrier is being output. So it's basically what we see here. And in first gear, the gear ratio is 4.56. So I got 4.56 turns of the input shaft to 1 rotation of the output shaft.
So let's look at second gear. The way they get second gear to happen is they release that C3 clutch, and then they apply that 2, 3, 4, 6, 8 clutch. And by doing that, remember, my input is always coming in from this input carrier. I've direct from my input shaft through the C3 clutch housing into that shell. My second planetary gear set's always getting input. So if my second planetary gear set's always getting input and this sun gear is held by the C1 clutch assembly, the 1, 2, 7, 8R, that now I'm going to be driving this internal gear assembly at an overdrive. Now if I apply that 2, 3, 4, 6, 8 clutch, that's going to end up driving this rear sun gear in an overdrive, and if I'm spinning that rear sun gear faster than input shaft speed, and I'm holding that internal gear, my output carrier is going to be spinning faster.
Now in second gear, we're going to release the C3 clutch. So we're not going to directly drive that shaft that drives that rear sun gear. But what we're going to do is we're going to apply the C4 clutch. And the C4 clutch is going to take this internal gear and it's going to connect it to that shaft. And it's going to do that through this clutch housing. So here's that C4 clutch right here. And when it's applied, the speed of that internal gear is going to get delivered to the shaft, and at the end of the shaft is that rear sun gear. So by releasing the C3 clutch, and now I'm not directly driving from the input shaft, that rear sun gear, I'm going to force, and applying the C4 clutch, I'm going to force that rear sun gear to go to the same speed as the second planetary internal. And as you can see, that is actually going in an overdrive. It's actually spinning a little faster than the input shaft. So what I'm effectively doing is I'm going to take this rear gear set that was spinning with the rear sun gear at input shaft speed and the internal gear held and the carrier out. I'm going to go ahead and spin that sun gear a little faster. So the best way that I can show this, once again, it'd be better if I have like 3 hands or something like that. Realize that the second carrier is always connected to the input shaft, so it's always spinning engine speed. But if I go through and grab the shaft that's driving the rear sun gear, put my finger on that internal gear that the C4 clutch is driving, and make those go the same speed, you can see that this rear planetary gear set, if I were to compare the speed of this shell to the output, is going to spin in a gear reduction. And that gear reduction is 2.971. So the output is still the rear gear set. We're still using the sun gear and the carrier and the internal. The carrier is the output, internal is being held, and the sun gear is the input. We're just taking that rear sun gear, making it spin a little bit faster, so our 1-2 shift basically overdrove that rear sun gear to make the 1-2 shift occur.
And now for third gear, you're going to see a little bit of a trend going on here. So 2 ways that we can reduce our gear ratio and go a little bit faster. One way is, like we saw when we shifted from first to second, is instead of driving a part at input shaft speed, we can maybe drive a little faster than input shaft speed. But another way we can do it, like you'll see here in third gear, is instead of holding an internal gear assembly or a gear set component, we can start to rotate it slowly. And every time we shift it, we can maybe make it rotate a little bit faster. So between the combination of making parts that were held rotate, or taking parts that were going input shaft speed and making them spin faster than input shaft speed, we can make these upshifts occur. So you're going to see that happen in third gear, because what they're basically accomplishing here is that we're going to go back to driving the sun gear at input shaft speed, but we're going to rotate our internal gear assembly. So it's not going to be a held component anymore. It's going to be a rotating reaction part.
Now in third gear, we had to release the C1 clutch release that input sun gear assembly so we can let it react and rotate, we still have our C2 clutch applied. And our C2 clutch is holding the third planetary gear set's internal gear. So that's going to be our part that we're reacting off of that's held. Now up front, we got our C3 clutch reapplying, and we've got our C4 clutch. As with a lot of transmissions these days, this transmission doesn't have any roller clutches, no sprags, no ratchets, no one-way rollers. So no one-way clutches at all. So this is a clutch-to-clutch transmission. So like most of these transmissions, when you shift from one gear to the next, you have to release a clutch and apply a clutch. And in this case, they're going to go through and they're going to release the C1 clutch and leave the C2 clutch applied. And then they're going to come back and they're going to reapply the C3 clutch. The C3 clutch was that clutch that went through and directly drove the input shaft. But now by leaving the C4 clutch applied, we are connecting, we're kind of locking this whole input gear set assembly together to make it spin at input shaft speed. So then you might be like, well, wait a minute, if we're gonna drive this front assembly, including the sun gear, at input, that rear sun gear at input shaft speed, wouldn't we be back to first gear? But that's not the case, because since we released the C1 clutch, now what we're gonna be doing is we're gonna be forcing that rear internal gear to spin a little bit of it. Instead of being completely held, it's gonna rotate a little bit. So once again, I'm using like every finger on my right hand to try to get this accomplished, but I'm rotating the second carrier, I'm rotating the internal gear, and I'm also rotating that rear sun gear, making all that stuff spin at input shaft speed. All the while, I'm holding the C2 clutch. As you can see, that rear internal gear is rotating at a slight gear reduction, and by forcing that rear internal gear to spin as opposed to being held stationary, we're taking some of that gear reduction away, and that was our shift from second to third. So since we have two output gears, we got this rear output gear set, this rear planetary, and we also have this front output gear set, this front planetary gear set. The output's going to come from one or the other of those two gear sets. And the way they can get a shift to occur is the best gear reduction you could ever get is if you've got the sun gear as input and the carrier as output. So if you're upshifting, you can do one of two things. You can make the sun gear spin faster every time you shift, or you can actually make the internal gear go from held to kind of a rotating component. And that's why we call those reaction parts, is because it's a rotating reaction piece. Instead of just being input, held, and output, we have input rotating with reaction or with resistance, and then the output is going to still be the output component, but it's going to be reacting off of a moving, a held part that's moving. That's not making sense, so does it? But it's true. So, or it's kind of like if you're in an airport and you got those flat escalators cruising down, you could just stand there and you could just cruise and get to the end and say a minute. Let's say that thing's a football field long and it takes a minute to get from one end to the other. You don't have to do anything. You can just stand there, right? But if you walk, you'll get there quicker. And if you run, you'll get there even quicker yet. So you're still reacting off of that escalator belt that's moving, but you didn't have to be stationary. You could move. And that's kind of what we're doing with these gear sets, is that instead of just holding a part, we can create a moving reaction part. So as we move that part and react off of it, we're going to make the output parts spin faster. It's the best analogy I've ever made in my life. So now in fourth gear, they get a little fancy. So what you're seeing here is they apply the C4 and the C5 clutch assembly. And that's basically going to lock both of these internal gears to that rear sun gear assembly. And what we're going to accomplish by doing that is we're going to force this rear internal gear assembly. It's a reaction that's occurring across this whole gear set, front to back, and it's going to cause that rear gear set to spin, or that rear internal gear to spin even a little faster. Watch this, I'll explain it better. Now we're shifting from third to fourth, and just like before, we have to release a clutch and we have to apply a clutch. And where we're releasing a clutch is we released that C3 clutch. The C3 clutch was the clutch that went through, let the input shaft speed go straight through and drive that rear sun gear along with these parts up front. And I've released that, and I've kept my C4 clutch applied, so this second internal gear's still got input, but now I've applied my C5. My front internal gear assembly has got input. So I'm connecting those two together, doing that through the input drum assembly. So the C4 and C5 clutches are applied, locking those two internal gears to that rear sun gear assembly. And like we saw in second gear, that when the input shaft, which is always connected to the second carrier through that housing, you'll always see that, in this case, that second internal gear is spinning at a little bit of an overdrive. The front internal gear is trying to actually spin the opposites, reacting in the opposite direction. So by letting these two clutches lock these two together, and by continuing to hold my C2, you're going to see that rear internal gear, it's actually going to start rotating a little faster than it did in third. So as I mentioned before, this is one of those things. Now you're running or you're jogging. Let's go from first gear, you're standing still on the escalator. Third gear, you are walking on the escalator. Now in fourth gear, you're jogging on the escalator. So you stole some of that gear reduction away, and now what you've done is you've sped up these parts on the output. That's what's happening in fourth gear.
And now we release our C4 and reapply our C3, and you get fifth gear, like this guy says.
In fifth gear, we still have our C2 clutch applied, but what did we do? We disengaged finally our C4 clutch, and we reapplied our C3 clutch. Our C3 clutch is pretty active, as you can imagine. Well, what did that do? We still have torque going from our input shaft into that second planetary. The C3 clutch locked that housing right here to the input shaft through the C3 clutch. And our C5 clutch is now going to connect that input shaft housing, basically indirectly, to this front internal gear. So we can say that these two components are going to be spinning the same speed. Now I'm still holding my C2, and now what you're going to see is that rear internal gear, maybe you've guessed it, but it's spinning even faster than it did in fourth. So it took my gear reduction away, a little bit of it. Now I'm jogging a little faster. Maybe one could say even running on the escalator in the airport.
So sixth gear is as simple as first gear. Matter of fact, it's even simpler because in this situation, we don't have any holding clutches applied. We've got our 3 driving or input clutches applied, and that means the front gear set is going to be the output component. We've got 2 parts input, nothing held. Direct drive must result, and that's pretty much what this guy has to say.
Now sixth gear is the easy one. I went ahead and released my C2 clutch finally, and I've got my C3, C4, and C5 clutch, all 3 driving clutches applied. So what that's going to end up doing for me is forcing this whole gear set, mainly the front gear set, since I have all 3 parts, the sun, the internal, and the carrier, going the same speed, I'm going to have a 1-to-1 output, and that is direct drive.
So just like sixth gear, seventh gear is going to utilize that front gear set, and that front gear set basically is going to be output component. If you remember, that front carrier assembly is splined to the output shaft. And because that second gear set is going to be working in overdrive, if you look, we've got a sun gear that's being held, a carrier that's being input. This is that second planetary carrier is always receiving input torque because it's always splined to that C3 clutch housing. That's going to cause the second internal gear and that first planetary gear set sun gear to spin in overdrive because I have a carrier input, sun gear held. This internal gear's got to be spinning in an overdrive, and that internal gear and that front sun gear are one and the same component. So if you think of that front sun gear again, I've got an input shaft speed going internal gear. I got a sun gear that is going at a slight overdrive. That's going to force my carrier to spin in overdrive. That's pretty much the same thing that this guy's going to say, but he's probably going to say it better because he's smarter.
So in seventh gear, we release the C4 clutch and we apply the C1 clutch. And the C1 clutch, what it's going to do is it's going to hold that second sun gear and in this gear set. If you remember, as I've mentioned a million times already, that second carrier assembly is seeing input from my input shaft. So right off the bat, I've got a sun gear that's held, a carrier that's input. That's going to cause my second internal gear to spin at an overdrive. Carrier's input, it's the biggest gear, so whatever gear it's driving is going to spin in overdrive. In this case, it's the internal gear. And it just so happens that that second internal gear is connected to the front planetary gear set, sun gear. So we're spinning the front planetary gear set, sun gear, at an overdrive. And the front carrier is the output component. And if I'm driving through my C3 and my C5 clutch, if I'm driving engine speed, my internal gear And through the reaction of all these parts, my front sun gear is spinning in overdrive. My front carrier is going to spin in overdrive. I've got a engine-driven speed in front internal, an overdriven front sun gear, which causes an overdriven front planetary. That'll be 7th gear. That's our first overdrive gear. And you can see this is giving me an overdrive gear. Over to the side here, I made one rotation around, and I made about 0.845 rotations. Wow, that just so happens to be the 7th gear overdrive ratio. Figured that out just by looking at it. All right.
And now we are here in 8th gear, the final gear. Thank God this thing's not a 10-speed, right? But what's occurring here is the gear set, the overdrive that's occurring from our 2nd gear set is basically being transferred over to our front gear set. Because what we have here is the sun gear that's being held stationary by the C1 clutch. And we have a carrier assembly that's being input. It's always being input through that input shaft. It's a direct connection. So the overdrive that's occurring in our internal gear, it's going to turn around and deliver that right from our front gear set right to the output of the transmission.
So here we are in 8th gear. We're going to look for the best overdrive that this transmission can produce. And what they've done, we still have the C1 clutch applied, and the C3 clutch is now released. But what they've done is they applied the C4 and the C5 clutches together. Remember, through our drum assembly, when both of those clutches are applied, they're going to lock these internal gears together. And what happens there is we still have an engine that's driving at input shaft speed, the 2nd carrier. We still have, through our C1 clutch, we're still holding that sun gear for that 2nd planetary gear set. So that means we're still overdriving. This stuff here is the same as it was in 7th gear. We're still overdriving that 2nd internal gear. But now we've locked the 2nd internal gear and the front internal gear together. So both of those are going to be spinning a little faster. Whereas in 7th gear, the front planetary gear set, internal gear was spinning a little slower. Now we're going to force it to spin faster. Remember I was talking, when you're upshifting a transmission, you're either going to make the sun gear, like in this situation, the sun gear go faster, or an internal gear start rotating or go faster. In this case, we're going to make the internal gear go faster. So if I continue to hold my C1 and I connect my C4 and C5 together, these two internal gears, and pretend like those are rotating, you could see we're getting a pretty stout overdrive. I'll go ahead and put some marks on there. So this is input shaft speed, that's output speed. Is I'm going to pretend to be clutches C4 and C5 and drive these two parts together. We're going to look at how fast the input shaft speed would go and compare that to how fast this output speed. Put my finger on C1, hold that sun gear, and we'll see what kind of overdrive that we can get out of this. And there's one rotation right there. And I haven't seen my red mark come around. It's right there. And that looks about 0.652 to 1 gear reduction, give or take. Couple thousandths. And that's what we have. Those are our 8 forward speeds and their power flow.
Just when you thought we were done, we still have reverse to go. Yeah, you like your forward speeds, but you still need to be able to back up now and again. So the way they get reverse on this is they have our C1 and C2 clutches applied, and our C5 clutches also applied, the 4, 5, 6, 7, 8R. And the way they accomplish this is they go through and they make this front gear set spin in a reverse rotation that actually causes our sun gear to spin counterclockwise, and that ultimately gives us a counterclockwise rotation of our output gear assembly.
So reverse is another one of those gears where it's kind of difficult to show because I don't have enough hands and fingers and can't drive enough parts, need an extra arm. And but the premise is typically what you have is you have a carrier being held. And in this case, they're doing things a little different. We're holding our C1 and C2 clutch, and this C1 clutch has this 2nd sun gear and 3rd sun gear connected to it. But when we hold that 2nd sun gear, and when I rotate my 2nd planetary through my input shaft, you can see this front internal gear is spinning in the opposite direction. So what's going to end up happening in reverse is that's going to deliver a reverse rotation to our rear sun gear. So if I connect through my C5 clutch, apply that through this clutch housing right here, and that delivers at reverse rotation to my rear planetary gear set, that's gonna, as long as I got the C1, C2 clutches applied, that is going to end up giving me my reversed rotation. So pretend that the engine is driving this clockwise as you're seeing it in the video, and you're gonna see the rotation on the output shaft going counterclockwise at a gear reduction.
Well, that about does it for part 2 of this 7-part series. And in this presentation, we talked about the 8 forward speeds in reverse. We talked about the ID, the transmission unique number, the sticker on the side of the transmission case. We mentioned the 4 planetary gear sets, the 5 clutches, 2 holding, 3 driving clutches. We mentioned that the second carrier assembly is always driven by the input shaft, or the turbines, always driving that, providing torque to it. And we also mentioned that the output was always coming from either the 1st or the 4th planetary gear set, and that this is a clutch-to-clutch transmission, meaning that there are no rollers, no one-way clutches, no sprags, no ratchet-type clutches, that every time a shift occurs, one clutch has to release and another clutch has to apply, and the timing is critical. That means all the clearances and the specs are tight and critical on this transmission. So the next lesson is going to be hydraulic operation. That'll be part 3, and I'll see you there.